Alright, so YouTube, this is kind of take two. We're just going to start it over from scratch because I realized that I left one, audio out of a screen that we're going to switch to in a second, and two, was having some issues where OBS was just kind of overloaded. It's resource intensive and it happens every now and then, so at least now I've fixed that issue. We can be a little bit more aware of it, and if anyone jumps in on the live stream and notices it, feel free to push a message through letting me know to check it. But what we were talking about previously, if you were on that video and now coming back, just to recap, is we have a controller here. We are going to go ahead and do a replacement of the analog joystick. It's been previously tested and found to have an issue with it. Now, that issue may not be solved by just simply replacing that joystick. And if it's not, at that point, it's probably not worth investing in fixing this all the way, just because the amount of labor and parts involved would be better served just buying another one and making this a part piece. So, without over-explaining it, seeing how this is the second time around, we're just going to jump right in. The first thing I'm going to do, because this is a nuts to bolts, start to finish, is we're going to change our view, and we're going to go to what I've set up called a controller capture, and that's where we are going to show how I test the controller to determine what needs to be fixed and then make a decision on how to go about repairing it. Alright, so we now have added in, if you were watching on the previous video, I did not have the little video of the controller still in place so that you could see me as I'm going through these actions. We also did not have audio, which was the final nail in that stream's coffin, that it needed to go and just be started over, because without audio, what the hell's the point? So anyways, what we want to do is go and grab our controller settings from Windows, and we do that in devices and printers. You're going to see a large line of options depending on what you have connected. But what we want to find is the non-grade. See, these are grade, grade, not grade, fully colored. It means that one is active. It is the only controller plugged in. Now, if you have more than one controller plugged in, you will find that you may have multiples up there. But we want to select this one. If you can't figure out which one is yours, disconnect the extra controllers. You don't need them all plugged in. From this window, we now get the game controller settings, and we're going to go into properties. If you weren't sure how I did that, let's go back one more time. We're going to reopen this window by right-clicking on it and go to Game Controller Settings. Once you're in the Game Controller Settings, you can go to Properties. Notice now, and this is what I now have the better benefit of memory because we're going in this right after I did it versus days, everything on this settings menu at default looks fine. However, watch what happens when I touch that right joystick. And this is upside down. You're going to see that this is on the left-hand side, but that's okay. We're using the right joystick. And I had my video playing, and it started talking back to me, so I needed to mute it. Okay, somehow my mouse was activated and scrolling up and down. Alright, so again, on live stream, anything that can go wrong will go wrong, and I just tried to talk over myself. So now that that's muted, let's get back on point. And that is, watch what happens to our window here, and that's this window, when I go, and that's the one with the 3 red lines. You want to pay attention to that bottom red line known as the Y rotation. As soon as I touch it, you notice that I gave it a flick with my finger, and I think really before I even put any weight on it, as soon as it sensed an actuation of its device, it lost its centering. What that means is that it's going to constantly receive this signal, whether you press it or not. And once that happens, that controller is no good to you. It needs to be fixed. Now, some things like, button issues, D-pad issues, sometimes they get a little bit more complicated. But analog sticks, unless you are skilled with a soldering iron, you probably want to take that to somebody to get it fixed. I think pretty much almost every major metropolitan area should have somebody nearby that does repairs on controllers. And they're not always the most profitable repairs. It's something that I think probably most repair shops would do just to help out their customer base. The more that we can interact with you and build that relationship, the better for us. But it's not always profitable for them, and it's not always cost effective for you, the consumer. So don't be upset if they tell you it's just not worth repairing. And we may find that that's the case with this one. But in order to find that out, we're going to have to take it apart, and we're going to have to test this, or replace it, then test it again. But before we do that, let's go ahead and let's run through everything. We're going to go through the full gamut. We're going to do our ups, our downs, our lefts, or is that our, yeah, that is our left. And then our right, doing this upside down. We're going to do our A button, and you'll see A button, B button, X button, Y button. Notice how they follow a pattern. A, B, X, Y, alphabetical order, 1, 2, 3, 4. Now for our 5 and 6, I believe that is going to be triggers. So left trigger, right trigger, and then 7 and 8 is going to be, well, sorry, bumper. Left bumper, right bumper. Left trigger is our Z-axis. And notice that has a little bit of off-centering, but I think that can be corrected through calibration because it's not fluttering, it has no jitter to it. It just isn't quite exactly center when it's sitting still. And then we have our, what is our next, is our X and Y axis for our right, which is here. And that should also stay still. It should come back to center. If it's not coming back to center, or if it's not maintaining a steady state, if it's fluctuating, if it's doing this, and I'm forcing this to happen, but if yours is doing this on its own, and it's just a minute movement, then you've got a problem with that joystick. So, left and right, or sorry, right joystick is up top, your X and Y. Left joystick is in that square to the right of it. And notice now our Y rotation on our right joystick, that red bar is all the way down to the bottom. So for 7 and 8, we've got our menu and our options buttons, and those are working fine as expected. And it depends on your controller model, but sometimes this is actually a button. On this one it's not. It's actually going to send a signal to Windows, and we're going to close that window so that it, come on now. Alright, so I closed that window so that it was no longer popping up an admin screen that had blocked out everything else. And we did 7 and 8. I'm no longer getting interactions from my controller. Let's go ahead and go back out. We're going to go back in. Oh, what the heck? I had to unplug and replug because, again, it's not responding now. Okay, we are getting nothing from this controller. So it does respond every time I press the Xbox button. There, now we've got a response. I don't know what was going on there. This thing may actually have an IC, and by IC we mean, or may actually have an IC issue. But by IC we mean the integrated circuit for the controller. That's kind of like the signal switcher that kind of communicates and does all its magic in the background and connects everything in the middle. Without that, it's the brain. That's a good way to put it. Without that brain, it's doing nothing. So let's get back to our view where I can see what the heck is going on. Alright, so we've checked 7 and 8. We now need to do 9 and 10, which are our depress buttons on our L3 and R3. So those all work fine. So far, this was our only issue, in that going blank state, not responding, regardless of disconnecting, reconnecting, until it finally decided to kick back in. the IC chip inside of this could be in a fail state, or it could have just been a glitch. We'll find out in a moment. When we replace this, if we still have these same issues, then we're looking at a bad IC chip. Alright, so we can close that window out. We're going to come back to our Logitech window. And we are going to go ahead and just to show, no batteries. Batteries not necessary for the test that we were previously making. Now, you are going to have to just pop this seal here. And where's our little handy tool for prying this open? You need something thin and flat. I've even filed this down to get me an even more fine pitch on my and they are stubborn. They will fight. But once you can get them rocked open, all you do is pry them up. The ones with the rubber grips, a lot of people will try to remove the rubber grip thinking that there's screws underneath, and they end up jacking up their controller. There is no fixing that because it's molded into the plastic at the time of manufacturing. I think they would call that an injection mold. Now you could just kind of place the plastic back on there. And let's do it this way so that you can see. There are 5 screws in total, 1 in the center and 1 on each corner. These are security screws, so you will need a specialized security bit. That one just doesn't want to come out, so we're just going to leave it. When we pry it open, it will then unjam itself from whatever edge it's caught on. And I forget what size this is, but this is a T8 security bit. And I checked just to make sure I wasn't misspeaking, but yes, they are security bits. Notice that your motors, these are your vibration motors, are not mounted. The way a vibration motor works is it's a motor that spins a cylinder, but that cylinder was cut in half. And the different weights of those cylinders create different levels of vibration, and that is how you get your rumble. They kind of get to be a pain, so I like to do this. I just take some masking tape. I tape them in place, and no more popping out motors until we're ready for them to remove themselves. I normally don't put it on until I actually get it off, so we're just going to cut that. I'm forgetting my steps here, trying to rush through it. Okay, so now that we've got the front plate off and the back off, we now need to, actually I wasn't rushing my steps, we need to remove, I've just got, no more taped, pry that up. Sometimes it's easier than others. Okay, that is 5. I was like, did we get a 6th screw out of that? I guess I can't count today. Alright, so now that this is off, taking these off is as simple as popping them off here. And then we need to remove this top piece here. We're going to lift and pry, and then it pops out. Now there is the little sync button. That piece, make sure that you don't lose it. I have lost those before, and you spend quite a while looking for them. So now, once you have it down to this level, we're basically at the board level here. Now, because I'm going to be using a desoldering iron, I get to do things a little bit differently where I don't have to fully dismantle everything. I can just pry off this back piece. I can desolder out, pop them through, put a new one in, and we're good to go. And that is what we're going to do here. Now, the one that we actually want to do is the right one. So we want to make sure we don't do the wrong one. Otherwise, then you're doing extra work for nothing. Now, the Xbox boards, PlayStation is different, but they all usually have multiple parts to them. If you have an Elite controller, it's even a little bit more complex with some other stuff. Scuff adds in the extra circuit panel and ribbon cables and connectors, and if you have a mod chip, it goes even more. Are we screwed in? We are. Okay. I was like, I thought there were screws, but I couldn't remember. So you don't want to overforce anything, because usually if something's not just working, it's telling you something, and what it was telling me is that there was still screws left in there. And I don't think I kept out my little screw bucket that had the fits, but here it is. So we're looking for a teeny tiny little security bit. I think this might be too small. It is. So we want to go slightly larger. And there we go. Now this one is not a security bit, it's just a standard torque. And it is a, it's so dirty I can't read it. Microscope time. That is a T6. This is what that one is. And for this, there's just the two so we got the left and the right side. Let's go ahead and add some tweezers into this. Alright, now that those have been removed, look at how easy that comes out. It should be that hard, no more, no less. Now this is our audio jack. Not all of them have it built that way, but for the ones that do, it does make the swap out of that very easy. And I thought I didn't have to do this to do that. Okay, and this is where you get going on a video, you're trying to make things go for a certain amount of time, because I know the long videos are less interesting to watch. I actually, and just to show that, but let's go ahead, before I do it, I'm going to seal it back up, just to show that I don't even have to take it out because of the tool that I'm going to be using. But these are our analogs, alright? And there are chips all around these. And as you can see, there are some here, and we're going to look at this under the scope in a minute. But using a soldering iron and a desoldering wick, you tend to end up causing damage to something else, creating more work for yourself. If you don't have a microscope, you may not notice what you've damaged, and it can drive you crazy. So that is where these, I caution you, if you're going to attempt it yourself, just be prepared to take your time, and if you do run into trouble, seek the help of a professional. But we're going to go ahead and we're going to screw this back on. I don't do Xbox controllers as much as I do the PlayStation ones. And that's why it tends to throw me off between the two. With PlayStation, you do have to remove it. With Xbox, you don't have to remove it. Well, that's annoying. Where are our tweezers? Okay, so we got a screw that went down into our little sticky tape. So that's okay, we've got it back on track now. And I should have already turned this on, but I'm turning it on now. That's our desoldering iron, so that we can get that getting hot while we're putting this back the way we want to show it. Alright, so we're taking nothing off from here. All of this is going to stay the same. We are removing this right one, which means we want to work on this side here. We're going to now bring in our scope, and I am going to make the scope big plus the Logitech. Alright, let's get ourselves set up here so that you can see what is actually going on. Alright, right now I'm just parfocaling the camera, so don't worry about what it looks like on your end. I'm just trying to make it so that when I adjust, it's already set up so that you can see the best view. Alright, so I think that's pretty good. We're going to try to get as much of this into shot as possible. Alright, so what we're doing now, and I am back to using my my little Chinese version of a soldering iron here. And that is because the paste had to go back to the manufacturer. That new ADS 200, they sent me a new chip to fix an issue that it was having, and the new chip fixed that issue but created a different one where the system actually no longer would bring itself out of the automatic power off state in the instant setback stand. When you pull it out, it still said off, but it was driving without temperature control, and that would have burned up tips. It could cause you to use the wrong temperatures on your work, so that issue absolutely needed to be fixed, and they requested the entire machine back so that they could troubleshoot the problem. So I sent them back my machine plus a couple of my tips and the same instant setback stand to make sure it wasn't a defect in that. It'd be nice if we were getting some heat here. Okay, so that is the bad tip. It appears that I blew out one of those tips. I didn't even know that was possible. So they've never done it with as much hell as I put this little cheap Chinese station through. Alright, so now this is mildly activated flux, so we're not going to add any flux at the moment. But we're going to go ahead and pre-tin all of these before hitting with them with the desoldering iron. And you can get, you know, the little cheap hand pump desoldering irons. There's even some electronic ones, but they're more so made for 220 volt supply. So if you have a converter, you could try those. But you can pick up a Chinese knockoff of the Hacko system for about 100, 150 bucks. And I think those work probably halfway decent. I decided that it was worthwhile to invest in the paste one. I'm not sure if I actually think I made a good purchase. I might have maybe should have spent the extra 600 and gone for the JVC unit. But the more I use it, the better I'm getting with its quirks, and it seems to get the job done. Now I'm going to go ahead and I'll tell you what, I will put at least a couple of these in through the camera or the magnifier just so that you can see it, and then I'm going to lay this flat. Alright, so what we do is we heat it up and we run it in a circular motion so that you hear that, I don't know if you can hear the squeaking, but we want that pin to move. And then we can hit the vacuum, and I don't know if that actually did anything, and that can be because the vacuum is clogged. So we're going to clean that out now. It doesn't appear to be clogged. I'm going to add some flux. Let's try this again. Alright, so I guess it just needed some flux. Alright, and so take a look at that through the camera. That has been completely desoldered. There may be a little bit sticking from the sides to the wall, but those will pop right off with a little bit of pressure from some tweezers. And the way that you want to do this is, again, rotate it around, let it heat up and let it wiggle that pin, and then suck, and then before you release, pull away. Now this is a bigger one. This is a ground. So we're going to give it a little bit more time to settle. And then we do the same motion. We suck, and then we pull away so that we don't clog our tube as this is going through. And with these, they're a little bit bigger and more strange, but I just do a up, down, and a left, right. I do that Konami code on it. And then eventually, it gets to where I need it. Alright, so that was all the ground planes, and those are usually the hardest. And I gotta say, that time it seemed to work a little bit better. Now if you want to see what this does, let's take a look at this. See how that it sucks it all through? Let's go ahead and we're going to put a little more flux in there so this stays wet down the length of the tube and doesn't again clog up, causing us issues to not be able to complete the job. See how nice and clean those joints get when you do it this way? It's going to make removing this so much easier than trying to do it with a desoldering braid, potentially causing damage to the surrounding components. Now what makes desoldering wick a bit of a pain in the butt is, take a look at this. This is a very thick board, there's a lot of layers to it, and very good ground planes that cause a lot of heat sinking. And they're not necessarily huge around here except for the ones you're attached to, but remember, all these ground planes are attached, and they're usually attached by big masses in order to make sure that they have sturdy holds. And because of that, it's rapidly dissipating heat. And when it does that, you're also trying to remove heat from something that has almost like its own heat sink, but that's the steel case here. Good for construction, but bad for desoldering. So without this desoldering iron, my experience has been you spend way more time with these than you want to. But that is how I used to do it, and it's also why I used to not do any repairs for clients unless they were the elite gaming controllers, if they required things like joystick replacement, just because it was such a pain in comparison to what it was worth for someone to actually want to have it done. Now with this desoldering iron, I can get it done fast enough that it makes the repair worthwhile for all parties involved. I think this one, nope, that's going to pop off. So see how I'm just kind of making that work itself free? Okay, and on this one I was wrong. You do actually need to remove it in order to, if we had a little bit more, you know what, I might just, let's see if we can. So no, we don't have enough play to lift up and out. So I was right in my first thought that I was going to have to take these apart. I'll have to remember which one it is. There's one that I don't have to take apart. I can't remember if it's an Xbox but a particular model, or maybe it was the PlayStations that I don't have to do and it is the Xbox. I get them confused. But anyways, we're going to go ahead now and take back out the screw that I so diligently put back in the show. And we are going to try one to test it before we go and put it back in, just to see if it immediately removes that problem. Now, if we're still getting drift without that controller analog stick attached, then we know that right then our problem is with let's go back to our big view. And now we're going to go back to our controller capture. And look at that. As soon as we sent a command through, we've got an issue with XY rotation. So what this tells us is that our problem is not with the joystick. It is, in fact, with that integrated circuit, and therefore we do not want to proceed with this repair. Now, from this, the only thing that would have been different is that we would have then reinstalled one of these back in, we would have soldered it on, and we would have sealed it back up. So this is still a start to finish video, just unfortunately the finish was that it's not going to be fixed. Now, I'll tell you what, before we go ahead and commit to that, let's just, you know what, it's YouTube, we're making videos, let's see if we can disprove something that I've already at least proven to myself, and that is that in the past, when I have seen these issues, it has not been worth installing a replacement because it has always been an issue with the integrated circuit. But it only takes a moment to put this in. It's not hard at all. Alright, so what we want to do when we install this is we want to support it. And let's go back to our scope big and our Logitech. So we want to support it so that these pins are flush and protruding out as much as possible. And we want to have it even. However, we also got to figure out a positioning that allows us to have our thumbs out of the way when we're soldering. So what I've found to be best is to just go ahead and pinch it into place. Take your soldering iron. We're going to wet our soldering iron here. And we're going to go ahead and tack in some of these pins to lock ourselves into place. I'm not even sure if I got that in the video, but you can see now all we're doing is our analog stick sensors. Those are 3 and 3. And then we're going to do our contact button, which is our, in this case, R3. A little more solder. And clean these joints up. Alright, so now that that is done, there's our part. Now before we screw it back together, we can go ahead and we can open this up and we can check it. Everything is, what we want to see is that it's flush here. And we do actually have a lift right there on that button. It could be a little bit more lower. But for right now, just to test it, it's fine the way it is. But I would probably clean that up just to make it sit a little more even. We're going to clip it in. And come back and we're going to reconnect. And we're going to see if any magic happens where it automatically fixes itself. It's doubtful, but possible. All right. Well, I tell you what, now we get good action from that left, but it's still out of alignment. We're going to have now, we have the X plane is going to be in rotation without any press of the button. See how it's sticking past, and we're still not quite 50%. I tell you what, let's do a calibration test. And let's get this out of the way. Alright, so let's do... This is the one that always confuses me. It tells me to do the x-axis, y-axis, but then tells you to press all of the D-pad's corners, so I just do them both and see what happens. Alright, so now all the way up and all the way down. X rotation all the way up and all the way down. Y rotation all the way up and all the way down. Alright, so now calibration has been finished, everything is done, everything looks centered, and we still get funky results. So, as I said, it does seem to be better for some reason, but it's probably not going to be usable. And I just press to see if anything else would happen here. I may try this on a computer. Let's do one thing. We did have a little bit of unevenness, so let's see if we fix that. If we get what we're going to do is switch back to our scope plus Logitech, and we are going to now and I'm just being sloppy with the solder paste, but it's okay. All we want to do is just get it to where we can take some of this out. Doesn't seem to want to get those, and I really don't want to have to change my tip, but that may be what we have to do. Alright, so we got that one, got that one, got that one, and now you can see where and why live stream videos take longer than real life, and that's because you start wanting to do stuff just for the sake of the video, and it ends up making you take longer than what you would give normally to a project, but then puts you behind on others. Let's see if we there we go. Putting some solder on. Now those tips are poking through nice. I did think they were sitting a little low when I started to do this, but I mean, it looked like we had a really flush mount, and they're even still not as low as they were a second ago. All right. All right, so we are going to now try this again. Let's go back to our controller capture, and we will plug in. And let's see what we get. Check just to make sure we're detecting buttons. And we are still sitting off. So see, it's like now the X rotation is in this. Let's try our calibrate one more time. Let's reset the defaults, now calibrate. Alright, and alright, Z-axis is our triggers. Oh yeah, Y rotation is up and then down. And finish. Alright, so again, everything is centered, but the second we go to touch, we get an off, and yeah, there's just basically, we have an impedance in our integrated circuit that is causing this to be out of whack. This is going to detect that we have a slight downward depress on our Y axis, which is it's actually a slight up movement, because up goes down, down goes up, at least in terms of the graph. And then for our X, we have there versus here. So yeah, so there was a problem that did involve this, but it has either started in the integrated circuit and worked its way to this, or started here and then affect the integrated circuit that is detecting that signal issue. It could also be a chip leading up to that's doing some of the resistance modification. And again, this is where we just get into too many ifs and buts to make this worth for a $60 controller. I mean, by the time it's been repaired, you could just buy a new one. So that is a no-go. And I actually have, from this same customer, 2 more to go through, but we're not going to do those in the video. It's been long enough already. I think this shows everybody exactly what's necessary. The only thing we didn't show was doing the ground planes on this analog sensor. You would put in those ground connect pins. You would want to solder those after you put it back on. If you have already replaced yours and you're getting wonky results, hook yours up. If you're seeing what we just saw there, then it probably means you've got a circuit problem. If it's something like an Elite controller where, you know, it's $150, $180, I think now they're selling to $300, those are the ones where it gets worthwhile replacing those integrated circuits, because, you know, if you're spending 50, 60 bucks, it's still a significant less amount than the cost of a new one. Versus we try to keep these around a cost of like 25, 35 bucks to repair, depending on what's going on with them. This one's going to far exceed that if we have to put on a new integrated circuit. So that's it for today. If you like this video, go ahead and hit that thumbs up button. If you'd like to see more videos like this, let me know in the comments section, and make sure to hit the subscribe so that you get alerts and notifications of when new videos will come along. I do try to post weekly at least. However, as we just left out of the busy season, it had me kind of a little off target. But these videos should start getting back to the regular. And if there's something that I haven't done that you'd like to see, again, feel free to put that in the comments, or send me a message and let me know that you'd like to see a particular type, style, or if there's a change that needs to be made to the videos. Again, everyone, have a great day, and see you in the next stream.